Good morning, fourth graders. This is your math e-learning lesson for Wednesday, April the 8th. Today we're working on lesson 114, changing improper fractions to whole or mixed numbers. Well, first of all, your improper fractions, anytime your numerator, the top number again, anytime your numerator is the same as the denominator or greater than the denominator, you have an improper fraction. Remember, improper meaning something that's not proper, something that's not right in a sense. So anytime we have a larger numerator or a numerator that's the same as the denominator, these are called improper fractions. And when we have improper fractions, as you remember, because I know we did touch on this briefly a while ago, anytime you have an improper fraction, you want to change it so that you have either a whole number or a mixed number. So the first example that they give in lesson 114 is 13/5. They tell you if you have 13/5, which of course now you know is an improper fraction, then you need to change it so that it's either a whole number or a mixed number. And if you remember, we talked about this as a division problem. Okay, 13 is greater than 5. Okay, 13/5. So we use this as a division problem because remember, this is another way to show division. So that comes in handy here, where now you're going to say 13 divided by 5. 13 divided by 5. 5 goes into 13 two times. 2 times 5 is 10. 13 minus 10 is 3. And this is your remainder. And this is how you would write your answer to this simple division problem. Well, now when you're working with an improper fraction, remember then we have to figure out, okay, well, then how do we show this as our mixed number? Well, 13/5, what you do is the whole number that you have here, okay, the first number in your quotient here is 2. Let me just move this over. We have a little room here. So we take that 2. Our remainder, remember, the remainder becomes the numerator in your fraction. And the denominator is the denominator that you started with. Because we're still talking about fifths. We haven't changed that. 13/5 here. We're still talking about those fifths. Right? But now we're writing it as a mixed number, whole number, and a fraction. In order to do that, remember you think of this as a division problem, 13/5. So you're doing 13 divided by 5. Your basic division, you find out that you get 2 with a remainder of 3. That 2 becomes your whole number in your mixed number. Your remainder becomes the numerator. And of course, we still have fifths because that's what we're talking about, 13/5. Okay, if you take a look down at the very bottom of the lesson, they show you an illustration showing you that you have 3 circles, each divided into fifths, and 13/5 would mean that 13 of those pieces have been shaded in because each circle is showing fifths. And so they have shaded in 13 pieces. And then when you look at it as it's shaded in, you now see that 2 whole circles are shaded, and then in the last picture, the last figure, you have 3/5 shaded in, 2 and 3/5. Right? Top of the next page, they show you 10/3. They ask you to write 10/3 as a mixed number. So you have 10/3. Right? It is an improper fraction. 10 is greater than 3. You know you think of this as a division problem. You have 10 divided by 3. Okay, 10 divided by 3. 3 goes into 10 3 times. 3 times 3 is 9. Subtract. You get a remainder of 1. Okay, so this basic division problem, 10 divided by 3, you get 3 with a remainder of 1. So over here, to write that as your mixed number, your 3 is your whole number, your remainder becomes your numerator, and remember we're still talking about thirds, so the denominator stays the same. 10 thirds is equal to 3 and 1/3. And then example 3 asks you to write 12/4 as a whole number. 12/4 as a whole number. Again, your division problem, 12 divided by 4. 4 goes into 12 3 times. 3 times 4 equals 12. And there is no remainder. Okay, so 12/4 is equal to 3. Do you put 0 over 4? No, because you have no remainder. Just like this simple division problem here, there's no remainder, so we don't put remainder of 0. There is no remainder, so there's no need to do anything with that. 12 divided by 4 is 3. 12 over 4 is equal to 3. That's it, whole number. Remember, sometimes your improper fraction, you'll be able to convert to a whole number, and sometimes it will be a mixed number. Okay, if you go down to your practice, you are asked to change each improper fraction to a whole number or to a mixed number. Again, it depends on the problem, the division problem, whether or not you have a remainder. When you have a remainder in the division problem, then your answer will be a mixed number. When there is no remainder, then your answer is a whole number. Okay, it also says to draw a picture. So basically here, if we had to draw a picture to go with 12/4 is equal to 3, 12/4, okay, again, the fourths tell us that that's how many equal part each of our figures must have. In this case, I'm doing circles, okay. The fourths tell us that each circle has to be divided into fourths. The 12 tells us we need to shade in 12 of those fourths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? 12/4 is the same as 3. So I can have 3 circles, each divided into fourths. When all fourths are shaded in, that's 12 of them. Or, instead of 12/4, the whole number 3, because 3 whole circles are shaded in. Let's just do one other example with shading in circles. We had done 10 thirds. Okay, and when we converted the 10 thirds into a mixed number, it was converted into 3 and 1/3. So how do we draw a picture to go with this? Again, we're using thirds. Now let me fix this one. Okay, so we need to use thirds. 1. Okay. We need 10 thirds. 10 thirds. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's only 9, so that lets us know we need to go further. Here we go. 10. Okay, 10 thirds have been shaded in. I have circles divided up into thirds because that's what I need to have. I need to have 10 of those thirds shaded in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then if I take a look back, well, if I just gave you this picture and asked you to write a fraction that goes with it, you know it would have to be a mixed number because you see that you have 3 whole circles shaded in and 1/3 of another. Okay, so this is the illustration that would go with this fraction or this mixed number. But I do need to show that they're divided into thirds. Remember, when we're working with these improper fractions and you're doing your illustrations, you need to show how many parts each figure must have. So in this case, you need to show that each figure has thirds. Okay? And then when they're shaded in, you can see that you have 3 and 1/3 shaded in all together. Okay, so for your practice, let's go through. I'll work through the practice with you. All right, let's do that. Okay, So we have 7 halves, 12 thirds, 8 thirds, and 15 fifths. Okay, so 7 halves. Okay, we convert that, we need to divide. 7 divided by 2. Okay, 2 times 3 equals 6. 7 minus 6, 1, remainder 1. So this becomes 3 and 1 half. Okay, let's go through first and do the division part, and then we'll go back and add the drawings with it. Okay, so we have 12 thirds. We know that we're dividing. Basic division, 12 divided by 3 equals 4. No remainders. This is just a whole number. 8 thirds, we're dividing 8 divided by 3. 3 times 2 is 6. Okay, with a remainder of 2. Okay, that becomes our mixed number. 2, our remainder is the numerator, and the denominator stays the same. And then 15 fifths. 15 divided by 5 goes evenly. 15 divided by 5 is 3. So here you have the whole number 3. Okay, let's go back and do the drawings that go with it. So here we need to show 7 halves is the same as 3 and a half. 1, 2, 3. Okay, and they're halves, so each circle needs to be divided into halves. The 7 tells us shade in 7 of those halves. 1, 2, 3, 4, 5, 6, and 7. 7 halves are shaded in, which is the same as 3 and a half. 1, 2, 3, and a half of another one. Okay. 12 thirds is the same as 4 whole. Okay. Again, our denominator is thirds, so we need to have our figures divided up into thirds. Okay. And 12 of those thirds need to be shaded in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 thirds are shaded in, which is the same as 4 whole circles shaded. 8 thirds. Again, they're thirds, so each circle is divided up into thirds. 8 of those thirds need to be shaded in. 1, 2, 3, 4, 5, 6, 7, 8. 8 thirds are shaded in. It's also the same as 2 and 2 thirds. 2 whole circles and 2 thirds of another. 15 fifths. It's fifths, so each circle needs to be divided up into fifths. Okay, each one is divided into fifths. We need 15 of those fifths shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So 15 fifths are shaded in, which is also the same as 3 whole circles shaded in. Okay. Lesson 114, numbers 1 to 30. Please work carefully. Remember, you're looking to get the most number correct. You're looking to see how successful you can be, how many you can get correct by working carefully, neatly. And also remember to go back into previous lessons when you need to refresh your memory on how to do something. Also, please make sure you're spending about 20 minutes on IXL or Extra Math. And if you have any questions, you know where to find me. See you later. Bye.